Network Time Protocol, NTP. Let us explore the core host role of the Network Time Protocol, or NTP, the invisible heartbeat that keeps a global network in perfect synchronization. In a modern digital environment, time is more than just a convenience. It is a technical requirement. If the clocks on two different computers are off by even a few seconds, critical systems will begin to fail. Encryption certificates will appear invalid. The AAA authentication processes we discussed earlier will time out, and the syslog entries will be impossible to correlate during a digital forensics investigation because the events will appear to have happened in the wrong order. An NTP server is the specialized host that solves this problem by providing a single, highly accurate source of time for every device on the network. The architecture of the stratum hierarchy. To provide extreme accuracy, NTP uses a hierarchical system of stratums, which are levels of distance from a primary time source. At the very top is stratum 0. These are not computers. They are physical high-precision timekeeping devices, such as atomic clocks or GPS satellites. These devices are the ultimate authorities on time. Next is stratum 1. These are the primary NTP servers that are physically connected to a stratum 0 device. They are considered the master time servers of the Internet. Finally, we have stratum 2 and below. A stratum 2 server gets its time from a stratum 1 server over the network. Most professional organizations run their own stratum 2 or 3 servers, which then provide the time to the thousands of individual laptops, routers, and switches in the building. The mechanics of synchronization. UDP port 123. NTP operates using the User Datagram Protocol, or UDP, on port 123. Because NTP is a real-time protocol, it needs the speed of UDP to minimize delays. However, because even the fastest network has some latency or travel time, NTP performs a complex mathematical dance. It measures exactly how long it takes for a time packet to travel from the server to the client and back. It then calculates that delay and offsets the client's clock to account for the travel time, ensuring the synchronization is accurate within a few milliseconds. Security and digital forensics. From a cybersecurity perspective, NTP is a vital part of your defense. First, as a defender, you must be aware of NTP amplification attacks. This is a type of denial-of-service attack where a hacker sends a tiny request to an NTP server but spoofs the IP address of their target. The NTP server then fires a much larger response packet at the victim, overwhelming their network with unrequested time data. Second, NTP is the anchor of a digital forensics investigation. When you are analyzing syslog files from a security breach, you are looking at a timeline of events. If your web server thinks it is 2 o'clock and your firewall thinks it is 2:05, you cannot prove which event happened first by ensuring every host on the network is synced to the same NTP server. You ensure that your evidence is legally and technically sound. Troubleshooting with W32 time. On a Windows-based network, the Windows Time Service, or W32 time, is the primary engine that handles NTP requests. If a workstation is having trouble logging in or accessing shared files, one of the first things a technician will check is the clock skew. If the local clock is more than 5 minutes off from the domain controller's clock, the Kerberos authentication protocol will automatically reject the user for security reasons. Simply running a command to resync with the NTP server often fixes these mysterious login failures instantly. By mastering the hierarchy of the stratums and understanding the vital importance of synchronized logging, you will be prepared to maintain the chronological integrity of any professional network.